Hey guys, good morning. In Aeromechanics of Solids, in unit number 3, deflection of beams and columns. So in that we will go through the today's lecture on deflection on beams. So what does mean deflection of beam? It means that the amount of deflection depends upon its cross section. So let us take a beam which is we having the I section in 3-dimensional, right? This is a I-beam. So most of the railway track you will see the I-beam, right? So it depends upon the cross section and a bending moment. If you apply bending moment, it will take the load, right? These days strength and stiffness are the two major or main design criteria for a beam. For a civil structure or aircraft structure or mechanical structure or automobile structure, so they are designing as strength and stiffness is their main criteria. They're fixing as a beam, right? The beam should be adequately strong to resist a shear force and bending moment. So the main purpose of the beam is to resist the shear force and bending moment. In order to saying in other words, the beam should be more stiff enough to avoid the deflection than the permissible limit. So if you design a beam, means it should resist the deflection, right? So it's in allowable limit, right? So in this unit we are going to measure the value of deflection as well as the slope, right? So beam deflection. What is beam deflection? When a load is placed on a beam, the beam tends to deflect or sag. Already I told what is sagging, right? Kind note down. Sagging, hogging, right? If the beam or any member which bends like downwards, this is a reference, means the beam will bend downwards, means this is called sagging. If the reference is like this, the bend will occur like this, upward, means that is hogging, right? When the load is placed on the beam tends to deflect or sag. That means take this beam, we are applying a point load, then it will bend like this. This is called sagging, right? So what it means so it is unloading neutral axis. After you applied a load, it will make a distance y, that is maximum deflection at the midsection. So this is unloading neutral axis. After bending this axis, that this beam axis is elastic curve or elastic axis, right? The deflection in this beams plays a significant role in the design of a structure or a machine. I told already in mechanical and civil. So let us take example. In our lab we have the lot of structural components or aerodynamic component experimental work. The loads are taken by the floor, right? If the floor beams loading by a plaster on a ceiling, under they may crack due to some applied load. Like this floor can get cracked, but it should not damage the structure of the machine or a part, right? Under load, the neutral axis became a curved line and it is called an elastic curve. Only we are saying that the elastic curve of that neutral axis became as a elastic curve, right? The deflection y is a vertical distance between a point of elastic curve and the loading of the neutral axis. It means this is a vertical line, the distance between unloading neutral axis and the elastic curve. This is the terms we are using in our beam deflections, right? So let us take how we are deriving this. So first we need to get an equation, no?